Okay, so here we have special right triangles continued. And if you remember, we had our 45, 45, 90 triangle, and we also had our 30, 60, 90 triangle. And I like this idea of this a lot. These two values here, all these stars are the same number. So let's say if I had this star be equal to 7, then that means that this star and this star and this star, it's all the number 7. So I like to use the idea of star instead of x. So going forward, you're going to see more of that. And if you like, I would use this triangle as your base triangle. And the same thing here. We have our star value, our 60-degree angle, the side across from this, opposite of this, is going to be that star value times the square root of 3. It's just going to look just like this. And then our hypotenuse across from the 90-degree angle is going to be 2 times whatever that value is for star. Okay, so I'm just going to go back and look at what our examples are. I'm just going to do a couple more. That way we can see the use of the radicals in using in doing these special right triangle examples. So here we are. Where to start? Where to start? Well, we know that these two values are going to be the same value, right? So whatever x is, y will be. And we also know that there's going to be another standard value that's going to be across from 30. So if I'm looking at my 60, 90, 30, 60, 90, that means that my star value is across from 30. So I know that this one, number 9, is going to be my star value. So this one I can think of as, let's just say, purple star. So this is star number 1. And across from my 90-degree angle will be 2 times whatever our star value for our 30, 60, 90 triangle was. And here that's going to be 2 times 9, which is 18. So here we have z is equal to 18. And what we're going to have to do now is use the values that we found, our purple star value. Let's just make this the purple triangle. I guess I couldn't make it the purple triangle. There we go. Let's make this the purple triangle. And let's make this the blue triangle. And let's see. So we have already found that this one was going to be, this is star. So that means that this side here will just be star times square root of 3. So that's going to be 9 times the square root of 3. And now let's take a look just at our 45, 45, 90 triangle. We know that we're going to have an issue because typically this is going to be star times the square root of 2, right? But we have star times the square root of 3. So that means what we're going to have to do is, because we need to, it's multiplied, this value, this side, then in green here, we multiply it by the square root of 2. It makes it bigger, right? Multiplication makes things bigger. And we multiply whatever our value here, our green star value, we'd multiply that times the square root of 2 to make it bigger. So in order to make this value smaller, we have to do the opposite of multiplication. That means we need to divide 9 by the square root of 2. And just a reminder that we will take a multiplication, we will multiply by a very special 1, and this will turn into 9 times square root of 3 times the square root of 2 over the square root of 2 times square root of 2, which is just the number 2. And the top will turn into 9 times 3 times 2 over 2. So this is going to be 9 times 6 is equal to 2. So x is equal to 9 times the square root of 6 over 2, and y is also equal to 9 times the square root of 6 over 2. All right, let's look at another problem. Looking at the next one, number 20. Let's see. Here we have a 45, 45, 90 triangle. So I'm looking at these two values of the legs will be the same, and the hypotenuse will be that value times the square root of 2. So I'm looking at these two. Let's do blue and purple again. So here we have our leg here in green, which is 32. That means our other leg here in green will also be 32. And x, x value, this will just be 32 times the square root of 2. All right, so we know that, now we know that our side here in green is also going to be, here let me use white, 32. But this is across from our 90-degree angle, right? And so that's going to be 2 times star. So 32 is equal to 2 times, let's make this our purple star again. And all I have to do to solve for star is just divide both sides by 2. So we find that our star value is 16, yeah. And let's see, so our smallest angle will be 30 degrees, so that's this one in here. And that means that the side across from that smallest value, z, will just be star. So z is star, which is 16. And then finally, we have our 60. This one is usually the most tricky, but this one is just going to be purple star, our purple star, times the square root of 3. And so really, we find y is just going to be 16 times the square root of 3. And moving on, just looking at this last one, 30, 60, 90. So this might be a little bit tricky, but we know that this value is going to be star times the square root of 3 because we want our purple star here, and this is going to be purple star times 2. So this value for square root 21 has already been multiplied to be bigger. So it would look like this. 4 times the square root of 21 would be equal to star times, let's do purple star times the square root of 3. And this might look tricky, but it's actually a very simple thing to do. The square root of 3 over square root of 3 is just 1, so those cancel. And then over here we have divided by square root of 3. And watch this. 4 times, this is a property of radical. Whenever we divide the top and the bottom by a radical, it's actually, we can just combine it under one house. It's just like multiplication. So this is 4 times square root of 7. And so our star value is 4 times square root of 7. So this is 4 times square root of 7. And if I wanted to do 2 times that, this would be 4 square root of 7 times square root of 7 times 2. Well, that would just be 8 square roots of 7. So y is equal to 8 square roots of 7. This was x.